Matter can exist in different states: solid, liquid, gas, and plasma. The transition from one state to another involves the addition or removal of energy, typically in the form of heat. These transitions are known as phase changes or phase transitions. Understanding these changes helps explain many everyday phenomena and the behavior of materials under different conditions. Melting, solid to liquid. Process. When a solid is heated, its particles gain kinetic energy and vibrate more vigorously. At a certain temperature, known as the melting point, the particles have enough energy to overcome their fixed positions and move past each other, forming a liquid. Example: ice melting into water at 0 grams, 32 Ohmdorf. Freezing, liquid to solid. Process. When a liquid is cooled, its particles lose kinetic energy and move more slowly. At the freezing point, the particles no longer have enough energy to move freely and settle into fixed positions, forming a solid. Example: water freezing into ice at 0 Celsius, 32 grav. Vaporization, liquid to gas. Process. When a liquid is heated, its particles gain kinetic energy and move faster. At the boiling point, the particles have enough energy to break free from the liquid's surface and spread out to form a gas. Example: water boiling into steam at 100 degrees or 212 degrees. Condensation, gas to liquid. Process. When a gas is cooled, its particles lose kinetic energy and move more slowly. As they lose energy, the particles come closer together and form a liquid. Example: steam condensing into water droplets on a cold surface. Sublimation, solid to gas. Process. Some solids can change directly into a gas without passing through the liquid state when they gain enough energy. This occurs when the particles of the solid gain sufficient energy to break free from their fixed positions. Example: dry ice, solid carbon dioxide, sublimating into carbon dioxide gas. Deposition, gas to solid. Process. Some gases can change directly into a solid without passing through the liquid state when they lose enough energy. The particles slow down and settle into fixed positions to form a solid. Example: frost forming on surfaces from water vapor in cold air. Ionization, gas to plasma. Process. When a gas is heated to extremely high temperatures or exposed to a strong electromagnetic field, its particles gain so much energy that electrons are stripped away from atoms, creating a mixture of free electrons and ions. This state is known as plasma. Example: the ionization of gases in the sun's core or in lightning. Recombination, plasma to gas. Process. When plasma loses energy, the free electrons recombine with ions to form neutral atoms, returning to the gaseous state. Example: plasma in fluorescent lights, returning to a gas when turned off. The energy involved in phase transitions is called latent heat. There are two types of latent heat. Latent heat of fusion, the energy required to change a solid into a liquid at its melting point. Example: the energy required to melt ice into water. Latent heat of vaporization, the energy required to change a liquid into a gas at its boiling point. Example: the energy required to boil water into steam. A phase diagram is a graphical representation of the states of matter of a substance as a function of temperature and pressure. Key features of a phase diagram include triple point, the unique combination of temperature and pressure at which all three states of matter, solid, liquid, and gas, coexist in equilibrium. Example: the triple point of water is at 0.076 and 611.657 pascals. Critical point, the end point of the phase, equilibrium curve between the liquid and gas phases. Beyond this point, the substance forms a supercritical fluid where the liquid and gas phases are indistinguishable. Example: the critical point of water is at 354 and 22.64 megapascals. Everyday examples include cooking. Boiling water to cook food involves vaporization and condensation. Refrigeration, freezing and melting of water and ice making. Meteorology, formation of dew, frost and clouds through condensation and deposition. Industrial processes include metalworking, melting and solidifying metals for casting and shaping. Chemical engineering, separation of substances using phase transitions, such as distillation. The changing states of matter are a fundamental aspect of physical science, illustrating how materials respond to variations in temperature and pressure. Understanding these phase transitions not only explains everyday phenomena, but also enables technological advancements in various fields, from industrial manufacturing to climate science. Whether it's the melting of ice in your drink, or the sophisticated manipulation of materials in engineering, the principles of changing states of matter are ever present in our lives.